Hello my friends, and welcome to this new practical activity on multiple linear regression. So in this new section we're going to learn together how to build a multiple linear regression model on the same dataset that was introduced by Kirill in the previous lectures. And just before we start, I just want to make sure that everyone here is on the same page. This is the whole machine learning A to Z folder containing all the code and datasets, and right before this tutorial I gave you again the link to this folder, so make sure to connect to that link, and now we should be all on the same page, ready to start this new machine learning model, which is of course in part 2, regression. And now we're going to go of course to multiple linear regression folder, and we're going to start with Python to implement this model. Alright, so this is the dataset, and this is the Python implementation in the IPYNB format, which you can either open with Google Collaboratory or Jupyter Notebook. Make sure you also have the folder downloaded on your machine so that you can indeed get these files. Alright, so before we start the implementation, let me just explain again what this dataset is about. So remember, a venture capitalist fund hired you as a data scientist to train a machine learning model and actually a multiple linear regression model to understand the correlations between these features, which are the spend in R&D, administration and marketing, and as well as the state, and the profit of what? Of 50 startups. So in this data set, it's very important to understand that each row corresponds to a certain startup, and for each startup, well, you data scientists collected the following data: R&D spend, administration spend, marketing spend, and the state of these startups, and of course their profit. Because the goal for this VC fund is to figure out in which startup to invest based on these informations. So these are all informations that we already know from 50 startups, and therefore if you manage to train a machine learning model that can understand well these correlations, well, for the next startup you'll be able to deploy this model on these features to predict what sort of profit this new startup might generate. Okay, so for this fund you definitely want to build an accurate model. Alright, and now we can start the implementation. But before we start, I would like you to figure out what are going to be the first steps of this implementation, before I show it to you. Alright, so first I hope that the first thing that came to your mind is that indeed the first step is the data preprocessing phase. And remember, in the data preprocessing phase we start by importing the libraries, that's for sure. Then we're going to import the dataset, that's even more for sure. And then we will split the dataset between the training set and the test set, because indeed we want to train separately our model and evaluate its performance on a separate test set. Okay, so that's always required. But then, is there something else that we have to do here? Well, to answer this question, let's have a look at the columns one by one. Starting with R&D spend. So R&D spend is a numerical column, containing numerical values. And when we scroll down, we can't scroll down because there are only 50 observations corresponding to 50 startups. And we can see that here there is no missing data. So all good. Then second column, the administration spend. All the spend in administration, like paying employee salaries or anything else. So this column is once again numerical with numerical values, and there is once again no missing data. Perfect. So far our 3 steps of the data preprocessing template are good. The next one, column in marketing spend, well, same, numerical column with no missing data, all good. And now this column, the last feature, notice once again that all the features are in the first columns and the dependent variable which you want to predict in the last column. So back to this state feature, what reflex do you have in your mind now? You should have the reflex if you paid attention to part 1 data preprocessing. Basically the question I'm asking now is, do we need to apply a certain tool of our data preprocessing toolkit, which we built in part 1, into this dataset? Well, here the answer is obviously yes, because indeed this state column is non-numerical. It actually has some categories. It has 3 categories, which are New York, California, and Florida. And therefore, that's exactly the same situation as in part 1 data preprocessing. There is no order relationship between these 3 states, New York, California, and Florida. And therefore, we will have to apply one-hot encoding to that state column. And therefore, we'll have to grab a tool of our data preprocessing toolkit, and that's why I prepared it here, in order to indeed one-hot encode that categorical variable, the state variable. All right, and then the profit is fine, it is numerical, and besides there is, once again, no missing data. So that's what you must do first. You need to have a look at your data set. If it is not too long, you can check that there is no missing data, like we just did. If it is too long, then I recommend to apply your data preprocessing tool that handles missing data and deploy it on this data set. And then you must check if any feature is categorical. And here we could check that very easily. The state is categorical, so we're going to apply our one-hot encoding tool of our data preprocessing toolkit on the state column. And then, of course, we will apply all the rest of the 3 essential steps of our data preprocessing template. And once again, we will do that in a flashlight because this is a template where we only have one thing to change, which is the name of the dataset. Are you ready? Let's do this. Let's start implementing our multiple linear regression model. So I just double-clicked on it. If you like Google Collaboratory, feel free to open this link with me, open with Google Collaboratory. And if you don't like Google Collaboratory, that's totally fine. You can open this file with Jupyter Notebook, but from your folder, which you downloaded on your machine. All right, choose your favorite, and here we go. Let's implement our multiple linear regression model. All right, so first, remember that this file is in read-only mode, which means that we can't modify it. But no worries, we're going to create a copy right away by going to File here and then click Save a Copy in Drive. This will, as you can see, create a copy in which we will be able to re-implement this multiple linear regression model from scratch, because indeed, I remind that this course is an action-based course in which I want you to take action as much as you can, and therefore we're going to re-implement this whole model from scratch together, step by step, and I really want you to code with me at the same time so that the practical skill can really be well integrated in your head, okay? So let's do this. Let's first start by removing all the code cells here, and only the code cells, not the text cells, because I want to keep that well highlighted structure for this implementation. So here I'm just removing all the code cells. There we go, and perfect. So this is the whole structure of this implementation. We can have a look at it here. And indeed, that's why I wanted to brainstorm on the dataset with you first before showing you the structure, in order to make you think what we must do in the data preprocessing phase. And as we said, we need first to import the libraries, then import the dataset, that's for sure. And then here we go, we need to encode the categorical data, and more specifically that state column, which contains indeed 3 categories. And then of course we split the dataset into the training set and the test set. That's a must, and that will close the data preprocessing phase, and we will all be ready to start training, well, first building and then training the multiple linear regression model on the training set. And by doing this, our model will understand the correlations between all these spends of those startups and their generated profit. And so there we go, we will get a smart model which we will be able to use on new observations, and that's exactly what we'll do as a last step here to predict the test set results.